What do we do with this? This is, it looks at first like it'd be reverse chain rule, right? Because it's 4 minus x squared to the power of a half. So you're like, ooh, powers, I can deal with that, right? The reason why we have to introduce this trig substitution is because, well, can anyone tell me, what's the problem? Why can't I use reverse chain rule on this? What's missing? Because sometimes you should use reverse chain rule if you've got an integral that looks similar to this. There will be, I'm glad you mentioned that. There will be restrictions later on. We might as well take note of that, I suppose. That you've got a restriction, namely, what? Minus 2 to 2, right? But that's fine, because our boundaries are within that anyway, so no sweat. What you would need if you wanted to use just normal reverse chain rule on this is you would need an x out the front, or some multiple of x, because you need the derivative of the inside as well as the derivative of the outside, right? So if it looked like this, you wouldn't have any trig substitution, okay? Because you could put a minus 2 out the front, that would be minus 2x, which is the derivative in the inside, okay? But that's another question. If this is the question we've got, what do we do? Now, before you get started substituting things in, you've got to take notice of the fact that this thing here has 3 pieces, okay? You've got, number 1, your boundaries, or your bounds, right? Then you've got the function that you're actually integrating, okay? And then you've got the variable that you're integrating with respect to, okay? So 3 pieces, and you've got to substitute for all 3 of them, okay? You can't do sort of substitute one thing and then leave the rest, okay? So we've already got x equals 2 sine theta. I suppose since we've got x squared, right? If I square both sides, I get 4 sine squared, okay? So that's good. That'll take care of the middle part. But I haven't looked at the bounds or the variable. Okay, let's look at the variable first. How am I going to change this dx? If I'm changing everything else to thetas, I can't have a dx there, right? So what should I do to get rid of it? I should differentiate what I was going to substitute, right? So this is weird because x is the subject here, so we're not used to that. But if I differentiate this, I'll be differentiating with respect to theta, okay? So the derivative of 2 sine theta is just 2 cos theta. And you can see here, this is what will allow us to get rid of the dx. Okay, just to make it a little more obvious, I'll toss that d theta on the other side. Okay, so now this is what I'm going to sub in for this dx. Okay, one more thing, you've got these boundaries. Okay, so a nice easy way to do it is to build yourself a little table here. Okay, you've got your x boundaries, namely 0 and 1. And you need to work out what they convert to for theta, right? So if x is equal to 2 sine theta, let's just have a look at 0, okay? So 0 is equal to 2 sine theta. So sine theta is just 0. So theta in this case would be 0. That's the angle which satisfies it, right? So for theta, 0 corresponds to 0. Now when you do 1, so this is a separate angle. Now when I do 1 equals 2 sine theta, okay? Divide both sides by 2. And you get a different angle this time, namely pi on 6. Good. And it's also important that you remember this. It has to be pi on 6. It can't be 30 degrees, right? Because we're dealing with trig and calculus, so it must be in terms of radians. So pi on 6. Great. Okay. So function, variable, boundaries. Let's go. All right. Instead of 0 to 1, it'll be 0 to pi on 6. Instead of the square root of 4 minus x squared, it'll be the square root of 4 minus 4 sine squared. Okay, so far so good. Instead of dx, I'll have 2 cos theta d theta. Okay. So here, under the square root, we need to work with this a little bit. You can take out that factor of 4, which when it comes outside the square root, that'll be just a 2. Right? Sorry, that's a 6. Very messy one. And then underneath here, I've got 1 minus sine squared. And 1 minus sine squared is cos squared, right? So I take the square root, you get cos theta. Okay? So I've got 2 cos theta here. I've got another 2 cos theta here. Okay? So therefore, I'm integrating 0 to pi on 6. I suppose we can... No, we'll leave the 4 there. Okay? cos squared theta. Now, do you remember, this is one of the ones we covered last lesson. What identity do we use to reshape cos squared so that we can integrate it? Because you can't do cos squared. It has to do with the double angle, right? For cosine, it's going to be 0, 6, 4 times a half 1 plus cos 2 theta. And of course, if it was sine squared theta here, the only difference would be the sign in the middle, right? It would be 1 minus cos 2 theta. Okay, we're almost there. This 4 times a half will just be 2. In some cases, it's easier for us to take that 2 outside the integral, but here it's actually kind of handy for us to have the 2, because you've got 2 plus 2 cos 2 theta, and that's going to be useful for our reverse chain rule. Okay? So I can now actually do the integrating step. So 2 turns into 2, sorry, not 2x, 2 theta. 2 cos 2 theta turns into sine 2 theta, right? From 0 to pi 6. Okay. Now, I'm going to be a bit naughty and just leave this here because there's only one step left. I now just have to evaluate, right? So when I've got 2 theta, that's pi on 6 times 2, that's pi on 3. And you've got sine of the same angle, pi on 3, right? Sine pi on 3, that's sine 60, so that is root 3 on 2. Now, when you evaluate the 0, right, so minus all of that, this is going to be 0 and that's going to be 0 as well. So in fact, I'm done. That's it. Okay? So again, the really important thing is that you get the 3 things that you've got to substitute all of them. Okay? The easiest one to miss is the boundaries. Okay? Most people catch the variable because if you don't do the variable, you've got this part and then you stick a dx there and you're like, oh, okay, clearly something's gone wrong. Okay? But people forget the boundaries because it's like, oh, 0, 0, not a messy looking 6, and 1, that looks okay, and then you just substitute in. Luckily for you, if it's a trig function, things start to look a bit weird because it's not, nice angles, okay? But still, people forget them. Alright, so boundaries, function, variable. Okay.